Hello, my name is Jonathan Karl. I'm a PhD student of Johanna Erdmenge at the University of Würzburg. And at this year's string conference, I present a poster about my recent paper with Ishovic, Banerjee, and Johanna, which is called Non-Locality induces Isometry and Factorisation in Holography. Basically, already from the title of the poster, you see that we focus on two aspects of the black hole information paradox in holography. The first one being the non-isometric nature of the bulk-to-boundary map, which is just a statement that in the semi-classical limit, the bulk Hilbert space is way larger than allowed by holographic entropy bounds. So therefore, this mapping from bulk to boundary Hilbert space has to be non-isometric. And then the second problem is the factorization puzzle, which is the statement that the Hilbert space of the two-sided black hole cannot be written as a tensor product, while the Hilbert space of the boundary theories is a tensor product. And equivalently, you may also phrase this problem as a statement about the boundary algebra of observables being type 1, while the bulk algebra is a type 3 one for Neumann algebra. And we consider these two puzzles in the following setup, where we consider on the boundary side two CFTs in the so-called time-shifted TFD states, which you simply obtain by time-evolving your ordinary TFD states, and then consequently you get these additional alpha phases here in the state, and they are dual to a two-sided eternal black hole with an identification between left and right boundary times along this red Cauchy slice here. And you can interpret either of these states as a microstate of this two-sided black hole. And then at a perturbative level, what you find when you calculate the overlap between these states simply from a path integral over this Euclidean cigar geometry here, you will find that these states are all orthogonal, and consequently they span an infinite dimensional Hilbert space, emphasizing the first problem. However, once you introduce non-perturbative corrections in your gravitational path integral, which schematically you can represent as these replica wormholes, then you will find that the states themselves are not completely orthogonal but have corrections. And then once you count only the linearly independent microstates, what you find is that they will span a Hilbert space with a dimension consistent with the central dogma of black hole physics, and then also consistent with holographic entropy bounds. And consequently, we get back the isometric nature of the holographic map. Now, for the second aspect of the information paradox, let me remind you that at large n, each black hole microstate is contained in a separate GNS Hilbert space, which looks like this. And it was shown by Leutholz and Liu that the algebra acting on this Hilbert space is of type 3-1. So schematically, the black hole Hilbert space separates into all these different GNS Hilbert spaces, and the transition between each of them is generated by the Hamiltonian, which can be included in the algebra, which then acts of this extended Hilbert space, and the local algebra will be of type 2 infinity. And now, as we showed, the non-perturbative corrections lead to a finite dimensional Hilbert space, and consequently the algebra is of type 1. And this type 1 algebra has discrete energy eigenstates, which you can use to span a factorized Hilbert space, which is then our proposed solution for the factorization puzzle. So that concludes my teaser, and I hope to see many of you at the conference and discuss together with you about this recent work.